Hello and welcome to this session. In this session we're going to be looking at prime factors. Now prime factors is just basically trying to break a number down into its most basic building blocks, kind of like the elements of chemistry. The reason that we do that is by breaking a number down into its most basic building blocks, we can start to compare it with other numbers that are much bigger than itself, but we can compare them. We can look for relationships like highest common factor and lowest common multiple. And again, techniques like that are important for things like the cybersecurity industry. It's also important for you because it will be on your GCSE exams. I'm going to try and show you different ways of breaking numbers down into their prime factors. We'll start with just a single number. So for example, 72. Now with the number 72, we can quite easily just half that. And if we half it, we end up with 36 and 2. I know that sounds a little bit confusing. Basically what we're doing is we're looking at the factors of 72. So what can multiply to give you the product of 72? Well, 2 times 36 will give us 72. Now you may remember from our previous lessons that 2 is a prime number. To make life easier for ourselves, we circle that. That just shows us that we've terminated that branch. It might be a good time to tell you that this is often referred to as a prime factor tree, because we have these branches coming off each number. So when we look at 36, well, we can divide that in different ways. So we could divide it by 2, or the more canny among you might recognise that is also in the 12 times table. So we can't do 12 and 3. Is 3 a prime number? You might remember that it is, so we just circle that. Now have a look at 12. 12 is part of that excluded list. It ends with a 2, a 4, a 6, an 8 or a 0. Now that ends with a 2, so it can't be prime, so we continue going. What can be multiplied together to give you 12? Different numbers can do this, so you can do 3 and 4, or you can do 6 and 2. It makes no difference which one you use. I'm going to use 4 and 3. 3 again is a prime number, so we can circle that. 4 isn't prime. What multiplies together to give us 4? 2 and 2. 2 and 2 are both prime numbers. So we circle those. Now in the exam, you will be asked to write 72 as a product of its prime factors. Now that is massive mathematical jargon. Write 72 as a product of its prime factors. Now that basically just tells you that you need to show how we can get to 72 using prime numbers. Now we have the prime factors there. Now to get from these prime factors back up to 72, we start multiplying. When we multiply numbers, it doesn't actually matter which order that we put them in, because we'll always get the end result. So I'm going to just start from the bottom left of the tree and work my way up. You can do it any way that you want. So I'm going to do 2 times 2 times 3 times 3 times 2. So just to show you, 2 times 2 times 3 times 3 times 2. Now you might see that there's 2's here, there's 3's there, and then we'll go back to 2. Again, that doesn't matter. You're still going to get the same result. If you write that, you will get a mark. However, you can get extra marks, i.e. if this was a 3-mark question, 1 mark will be for this prime factor tree, 1 mark will be for this part, this answer, and a 3rd mark will be to put that in indices form. Now indices form just basically means collect up your 2's. That doesn't mean that you do 6 times 6 or something like that, because you don't add them. What you do is you see what factors that you have. We've got a 2 and we've got a 3. And we count how many of each we have. We have 1, 2, 3. So we put a little 3 there, and we have 1, 2. So we put a little 2 there. That tells us that 2 to the power of 3 times 3 to the power of 2 will give us that. However, that is perfectly fine. You will still get a mark for that. But if you just learn to do that, you do have the chance to pick up that extra mark. This is just a prime factor tree. And all that you do is you're finding what multiplies together to give you the higher number. And as I've said before, in an exam, when you get given that question, write this number as a product of its prime factors. All that we mean is break it down into its prime constituents and multiply them together. You don't actually have to work this out, but if you did, you would just get 72, and that will show you that your answer is right. I hope that you found this helpful. Stay tuned for more.